So here we have a problem. Sine of the inverse tan of x. Really, what are they asking for? Okay, and what are these different pieces? What, in fact, is x? Is x an angle or a ratio? And is my answer going to be an angle ratio? That's a really key idea here. When we look at this expression, do we really know what the x is? Okay, so that's really the first thing we should be asking. We should also be thinking that, all all trig has an inverse, okay, and all inverses have an inverse as well, okay. So we have these two things, this trig function and the inverse function, they do opposite things, okay. One's going to give me a ratio, okay, so the x here would be an angle, and I get a ratio. Here I have a ratio, and the answer to this is going to be an angle, and they do the opposite things. The other thing that I have to be careful of is that the inverse trig functions have a restricted range. Okay, they have a restricted output because we can't accommodate all the angles. Otherwise, we end up with non-functions. Okay, so when we look at this problem here, the sine of the inverse tan of x, first of all, is x an angle or ratio? Okay, well, if the input to an inverse tan function is a ratio, the output's an angle, so then the input for the sine is an angle, the output for the sine is a ratio. So it looks like this. So I start with x as a ratio, I put it through the inverse tan, my output here is an angle, the angle then is applied to the sine, and the output should be the ratio. Okay, so when we look at this picture here, my x value is my ratio, so that's slope. So I have rise over run, and that completes my triangle there. That's the hypotenuse of the triangle. And when I think of the inverse tan function, the inverse tan function has a restricted output. It cannot find angles on this side of the circle. Okay, otherwise we have non-functions. So the inverse tan has a restricted output from negative pi over 2 to pi over 2. Okay, so we can't have theta 1, theta 2 case anymore, especially with the inverse tan. Okay, if we have tan theta equals, and we use inverse tan to find one angle, then the tan function is defined on both sides. But the inverse tan function is only defined on this side to make it a function. Okay, so when we're going to solve this problem, we start with our ratio. So we draw in our ratio, we complete our triangle, and that gives us our angle here. So it establishes our angle. Based on this angle, we want the sine ratio. So we want the opposite side to the hypotenuse. So the answer then is going to be x over square root of x squared plus 1. So we went from, again, the flow chart is very important. We start with a ratio, okay, this slope ratio. We end up with the angle, this angle here. And this angle is applied to this triangle as a sine ratio, and we want the sine ratio out of this triangle. Okay, so we could do it the other way around as well. Okay, here we've got the sine function embedded inside an arccos. So here we started with the inside was arctan, and the outside was the sine function. Here we've done it in reverse. So first of all, it's very important to establish, is the input x an angular ratio, and is my answer going to be an angular ratio? Okay, so here, this x here represents the angle. We take the sine of an angle. So this is going to give me a ratio, and this ratio is going to be given the arccos, so the output should be an angle. Okay, so it looks like this. My input angle, I take the sine ratio, that ratio is undone, okay, and then we get an angle. Okay, in this case it says arctan, but maybe we should change that to arccos for this particular example. Okay, and our output is going to be an angle here. So what does this look like? Okay, so my sine of x, here's my x angle. My sine of x in the unit circle is going to look like this. So it's radius 1. The vertical is going to be my sine. The horizontal is going to be my cos. Okay, So I've been given this angle, this angle here. My output for the sine function is going to be this length here, or the ratio. I'm going to apply the arc cos to it. So what angle has this line as a cos? Well, I'm just going to draw another circle here. If I redraw this picture and make this length the sine length, the horizontal length, okay, draw it like that. If this length here represents my horizontal length now, then the angle is going to be this angle here. So here the angle was x. This angle then must be the complementary angle, or pi over 2 minus x. So the output for this angle, this function is going to be pi over 2 minus x. Okay, so let me just clean this up a little bit so that we can see this a little better. Okay, I'm going to just change that to arc cos. Okay, it's going to be arc cos ratio. It's going to give me my angle. Okay, and there's my angle. My angle is going to be pi over 2 minus x.